This is lesson 10.2, finding arc measures and using chords. So a central angle is an angle with its vertex at the center of the circle and its two sides are radii, like angle ABC in our picture, because B is the center, AB and BC are both radii. All of the angles in the circle will add up to 360 degrees. The arc is the edge of the circle that's curved, defined by two endpoints. So between A and C, that would be arc AC, and we use a curve above it to show that it was an arc as opposed to a segment. The measure of the arc formed by those endpoints of a central angle is equal to the measure of the central angle or the sum of the central angles that form it. So in this picture, angle ABC was 84 degrees, so arc AC is 84 degrees. So we show that like this: measure of arc AC is 84 degrees. And because the whole circle is 360, I could take that away from 360 to get that the other arc, ADC, going the other direction would really be 276 degrees. We classify our arcs as minor, major, and semicircle. So minor arcs are named using two letters, only the endpoints, and they will always measure less than 180 degrees. So here arc AC is 110 degrees. Major arcs are named using three letters. They're going to use the endpoints and another point on the arc. There could be multiple points that it passes through, but we're only going to name one of them. So this would be arc DFE, because tracing along the outside of the circle, that's the points we would hit in that order. And because arc DE would have been 60 and the whole circle is 360, we take it away and we would get 300 degrees for that arc. A semicircle is exactly half the circle. So semicircles are named using three letters and the endpoints and another point. So it's going to be named the same way a major arc is. The measure will always be equal to 180 degrees, because if it's half the circle, it's half of 360. So that would mean arc JKL, or if I went the other way, arc JML would both be 180 degrees. So for example, 1A, we want to find the measure of each arc and identify it as major, minor, or semicircle. So the first thing I would do is if RT is a diameter, that's one straight line, a linear pair tells me this would be 70 degrees. And this side would just be 180 degrees. So arc RS, if I start at R and end at S, and I want to go the shortest way possible because it was listed with two letters, that would just be 110 degrees. Less than 180 is a minor arc. Also, two letters, automatically a minor arc. Three letters could be a minor arc or a semicircle, so we really do need to look. RTS, so we start at R, we hit T, and then we hit S. So we're using both arcs, RT here and TS here. So 180 plus 70 is 250 degrees. And that would be a major arc because it was more than 180. An arc RST starts at R, hits S, then T. So we're talking this part here. Since its endpoints were the diameter, that tells me it's a semicircle and it's 180 degrees. With another example, same idea, but now I know three angles in the picture. I know 40, 80, and 110. So total I have 230. So taking that away from 360, I have 130 left over for that one right there. So arc GE. G to E, shortest way possible, would go this way. So that's 40 and 80 combined, which is 120 degrees, which is a minor arc. GEF, G, then E, then F. So G, then E, then F. So we're going to keep going around, or I could say it's 360 minus 130, which is 230, and that's a major arc. And our third one is just FG, so just from F to G, shortest way possible, is 130 degrees, and that's another minor arc. Here's a check-in for you to try. Pause, answers are posted on Google Classroom. Congruent arcs. So two arcs are congruent if and only if they have the same measure and their circles have the same radius. So arcs can be equal when they have the same measures, but they can be congruent, remember our geometric property, when they have the same measure and the circles have the same radius. So for example, if I want to talk about arc CD and arc EF, which they've should say EF. They've highlighted in red for us. Both of them are 80 degrees, and they're in the same circle, so they have the same radius. So this would be yes, because it's the same measure and congruent radius. In B, for RS and TU, they're the same measure because they're both based on this 90 degrees, but the radius is different. RQ's radius is different than QU's radius. So no different radius. And in C, when I'm looking at UV and YZ, they're both 95 degrees, and they've marked that these radii are congruent. So this is another yes, because it's the same measure and congruent radius. So there's one here for you to try. You can pause. Answers are posted on Google Classroom. Example 3. We want to find the measure of arc AD and the measure of arc AB. So right now we know because these angles are vertical, these measures of these arcs would be equal as well, right? Because they were the central angles here. So I'm going to start by setting those equal. Take away our 8x. Add our 22. And divide by 2, so we get x is 17. So to find the measure of arc AD, I could plug it into 8x plus 12. So 8 times 17 plus 12. The measure of arc AD would be 148 degrees. So if this arc is 148, and this was a diameter, then this and this together have to equal 180. So 180 minus 148 would tell me that the measure of arc AB is 32 degrees. So there's one here for you to try. Pause. Answers are posted on Google Classroom. So using some chords, so remember that a chord is a segment where endpoints are on the circle. Any chord will divide the circle into two different arcs. If it's the diameter that's the chord, we actually have two semicircles, but any other chord will make a major and a minor arc. Two chords are congruent if and only if their corresponding arcs are congruent. So if I know that these two arcs are congruent, that makes these two chords congruent, and vice versa. If I know these two chords are congruent, I can say that those two arcs are congruent. So for example 4, if arc AB is 110 degrees, and these are both 9, then arc BC is also 110 degrees. In B, if arc AC is 150 degrees, we know that these two chords are congruent, making these two arcs the same. Together we add to 360. So 2x plus 150 equals 360. Take away the 150, 2x equals 210. So that would be 105 degrees. There's one there for you to try. Pause. Answers are posted on Google Classroom. The last thing is if a diameter of a circle is perpendicular to a chord, and the diameter bisects the chord and its arc. So as long as there's a radius or diameter coming in through this thing and it's perpendicular, then those two pieces are the same, and those two pieces are the same. So for this example, we want to find the length of HK, which is the segment inside. These two pieces have to be the same, which is another 7 there. So the entire length of segment HK is 14. And they also want arc HK, so they want this whole arc here. Because it was bisected, these two pieces of arc are equal, so we will set them equal. Take away x, divide by 10, so we get x is 7. And the whole of arc HK will be adding up these two parts, so 11 times 7 is 77, 70 plus 7 is 77. So arc HK will be the 77 plus 77, which is 154 degrees. The final one for you to try is right here. Answers are posted on Google Classroom. And that is the end of our section 10.2.